Hello student, good morning. I am Dr.A.K, Professor of Chemistry. Today I am going to discuss relationship between equilibrium constant, reaction quotient Q and Gibbs energy G. Again I am telling you, today I am going to discuss relationship between equilibrium constant Kc, reaction quotient Q and Gibbs energy G. Means relation between Kc, Q and G. This relation is very important. Okay. The value of Kc for a reaction does not depend on the rate of the reaction. Already many times I told you. Kc for a reaction does not depend on the rate of the reaction. However, already I have discussed it is directly related to the thermodynamics of the reaction and in particular to the change in Gibbs energy delta G. Okay. Kc is directly related to the thermodynamics of the reaction and in particular to the change in Gibbs energy delta G. If conditions are there, three conditions are there. If delta G is negative, then the reaction is spontaneous and proceeds in forward direction. First, already I have discussed in thermodynamics. Delta G is negative. If delta G is negative, then the reaction is spontaneous and proceeds in the forward direction. Second, if delta G is positive, then reverse case. If delta G is positive, then reaction is considered non-spontaneous. Instead, as reverse reaction would have a negative delta G, the products of the forward reaction shall be converted to the reactants. Means suppose products are giving reactant. Then now from the product you are getting the reactant. In that case also it will be negative. Delta G will be negative. Okay. Means if delta G is positive, then reverse reaction will be non-spontaneous. And if negative, then spontaneous. Okay. Negative means spontaneous reaction. And if delta D is positive, then non-spontaneous. Okay, means irreversible. Not irreversible. Delta G is negative, then it is spontaneous and irreversible. Okay, if delta G is negative, then spontaneous, or you can tell natural, or you can tell irreversible. And if delta is positive, then reverse case means non-spontaneous, okay, unnatural, or you can tell like that it will be not natural, unnatural, okay, and it will be positive means non-spontaneous and unnatural, you can tell, unnatural, not natural. Okay. And third point, if delta G is 0, reaction has achieved equilibrium. Okay. If delta G is equal to 0, it means reaction has reached or achieved equilibrium. Okay. At this point, there is no longer any free energy. If a delta G is 0, It means there is no longer any free energy left to drive the reaction. That's why it will be in equilibrium. Okay, then three condition I have told you, that if delta G is negative, then the reaction is spontaneous and proceeds in the forward direction. Okay, and if delta G is positive, then reaction is considered non-spontaneous. Okay, and third, if delta G is 0, reaction has achieved equilibrium. Okay, then now after this 3 point, now I am going to discuss relation between Kc, Q and G. Q means reaction quotient. Yesterday last class I have discussed. Then now see the relation between these three, Kc, Q and G. Then here there is a mathematical expression of this thermodynamic view of equilibrium can be described by the one equation. What are that equation? Then delta G is equal to delta G standard plus RT ln Q. This is the, you can say, first time I am telling you this relation. Okay, similar type of relation already I told. That time it was ln Q, same reaction, same equation. Delta G is equal to delta G standard plus RT ln K. I have told you, but first time I am telling you delta G is equal to delta G standard plus RT ln Q. K and Q, what is the difference? Last class already I have told. At equilibrium, when delta G is equal to 0, that time Q will become equal to Kc. Both will be equal at equilibrium. Last class also I have told these things. Okay, then at equilibrium what will happen? That when delta G is equal to 0, then Q will become Kc. Then you can write in the place of delta G, you write 0. Then 0 is equal to delta G standard plus RT ln K. Okay, 0 is equal to, because delta G is 0, then 0 is equal to standard delta G. Okay, means 0 is equal to delta G standard plus RT ln K. This is actually you can say main relation. Okay, then standard delta G plus RT ln K, that is equal to 0. Then what will be the value of delta G standard? Then very easy, just to rearrange. Then delta G standard is equal to minus RT ln K, because delta G standard plus RT ln K is equal to 0. Then just bring this RT ln K right side towards 0. Then it will become delta G standard is equal to minus RT ln K. Then what is the ln K? The ln K simply you can calculate. Then ln K is equal to minus delta G divided by RT. Okay, minus sign will change. Okay, because delta G standard is equal to minus RT ln K. Then ln K is equal to what? You have to divide by minus RT. Then delta G standard divided by RT. Hence relation will become ln K is equal to minus delta G standard divided by RT. This is the important relation. ln K is equal to minus delta G standard divided by RT. Now again you can make a little more change in that. You can say take both side antilog. taking antilog of both sides, then what you will get? Then you will get k is equal to e exponential, k is equal to e exponential minus delta g standard divided by RT. Okay, after taking antilog, this equation ln k is equal to minus delta g standard divided by RT will become k is equal to k ln k. Now we are converting to k, then after taking antilog, then k is equal to e exponential minus delta g standard divided by RT. Okay, this is again a new relation you got. Okay, only from the previous relation. Hence, using the, you can say this equation, k is equal to e power minus delta g star divided by RT, what you will get? The reaction, you can say, you can interpret from this relation, interpretation can be done, explanation can be done in terms of the value of delta g. Then here two conclusion you will draw. First conclusion, that if delta g, standard delta g is less than 0, if standard delta g is less than 0, then what will happen? Delta g is upside. In formula, k is equal to e minus delta g standard divided by RT. And if delta g is less than 0, then what will happen? Then minus delta g standard divided by RT will be positive. Okay, if delta g, standard delta g is less than 0, then minus delta g standard divided by RT is positive or will be positive. And then what will be full exponential? E minus delta g divided by RT will be greater than 1. Okay, if delta g is less than 0 and then delta g is upside divided by RT is there and delta g is less than 0, then minus delta g standard divided by RT will be positive, and complete e exponential minus delta g standard divided by RT will have greater than 1, will have value greater than 1. And when e exponential minus delta g standard divided by RT is greater than 1, then k value, it will affect the k value, then k value will be greater than 1, means both will be greater than 1, means exponential minus delta g standard divided by RT is greater than 1, and due to this k will be greater than 1. Okay, then what is the condition? If delta g, standard delta g is less than 0, this relation, this condition you have to keep in mind, that if delta g standard, if delta g standard is less than 0, then k value will be greater than 1. And when k will be greater than 1, then what will happen? If k is greater than 1, which implies a spontaneous reaction, that reaction will be spontaneous. Means what I have discussed earlier, that if delta g is less than 0, means reaction will be spontaneous. Okay, means negative. Delta g negative means spontaneous. Then delta g less than 0, same meaning. Then if delta g is less, the standard delta g is less than 0, then reaction will be spontaneous because k will be greater than 1. Okay, means in question and examination they will ask if K is greater than 1, then what type of reaction will be there, whether it will be spontaneous or non-spontaneous. Then now you are understanding it will be spontaneous. If K is greater than 1 means spontaneous. Last class also I have discussed. Okay, then I have told you that if K is greater than 1, then it will be spontaneous, means reaction will proceed forward direction. Okay, if K is equal to 1, then reaction will take in the forward direction. Okay, it will proceed to the forward direction. Now or you can say product will predominant on reactants. Reactant will be less, product will be more. Then first things I told you that if delta G is less than 0, if reverse case, if delta is greater than 0, then what I told you, all things will be in a reverse way. That if delta G is greater than 0, then minus delta G standard divided by RT is negative, and exponential minus delta G standard divided by RT will be less than 1, means K will be less than 1. Then if K is less than 1, which implies a non-spontaneous reaction, or a reaction which proceeds in the forward direction to such a small degree that only a very minute quantity of product is formed, means main thing reaction will be non-spontaneous. Non-spontaneous means product will be just only for sake very little amount will form, but it will be non-spontaneous. Reaction will not take place, and if suppose it is taking place also, then product will be very less. Okay, then I have told you about the relation between the Kc, Q and G. Then here Q in the middle, it is coming simply that at equilibrium, when Q will become equal to Kc, then only that time Q will be not seen in the equation. In the place of Q, Kc will come. Okay, only because we are talking at equilibrium, and at equilibrium both will be equal. Okay, then now I am going to discuss factors affecting equilibria. Numericals is there, and the end I will discuss the numericals also. Okay, then now first let me discuss factors affecting equilibria. Okay, many factors are there, like concentration. You know that when a reaction is at equilibrium, then it will be disturbed when you will add more reactant, or you can tell if concentration will change, concentration of reactant or concentration of product will change, then equilibrium will change. If temperature will change, then equilibrium will change. Third, if pressure will change, then equilibrium will change. Okay, then what are the factors? Then these three factors, means temperature, pressure, concentration, is main factors. But other two things also you should understand. If you will add additional substance, then what will happen? How will it affect? How it will affect to the equilibrium? And one more, that is if you will add catalyst, at equilibrium, then how will it affect the equilibrium constant or equilibrium? Okay, now these points I will discuss, and in examination many questions are asked, or questions are asked on factors affecting equilibria. Then now I am going to discuss these things. factors affecting the equilibrium. And here one principle is coming, that is the LECT-104 principle, because equilibrium will change when these factors, the actually concentration, temperature, if concentration will change, if pressure will change, if temperature will change, then how equilibrium will change, in which direction it will go, whether it will go to the forward direction or backward direction, where it will go, because there will be, only here I am telling you main things of this LECT-104 principle. LECT-104 principle. Sometimes pronunciation difference will be there. LECT-104 also they will tell, but it is LECT-104. LECT-104 principle. LE means LECT-104. CHATELIER. LECT-104's principle. Okay. Then what is actually this principle? LECT-104's principle. It is the name of scientist. L is separate. CHATELIER. CHATELIER. S post S. LECT-104's principle. What actually is this? Because you are going to disturb. It will be disturbed by these factors, temperature, pressure and concentration. Then how equilibrium will be disturbed? What will happen to the equilibrium? Where, in which direction it will move? Either in forward direction or backward direction, what will happen to the equilibrium? Then here you understand what is this principle, LECT-104 principle. Then according to the principle, that anyone, if it suppose equilibrium is disturbed by change of concentration, then equilibrium will readjust. And why they will readjust? Then whatever concentration, suppose you have made a change, then either it will increase or decrease, something will happen. Then equilibrium will re-established. Okay, equilibrium will be readjusted to avoid that effect. Means change of concentration. It will readjust in such a way that that effect should be neutralized, either by giving more product. Suppose reactant you are adding more, then it will give more product. Then only reactant will be avoided. If reactant you have added, then it will be neutralized. How? Then it will give more product. Then reactant will be neutralized. Excess reactant what you have added, that will be neutralized. Means that is, you will be used up. And then how? Then by giving more product. And again it will readjust the equilibrium. Then it will readjust or re-establish in such a way that effect should be neutralized. Okay. Then always readjustment of equilibrium will take place. Same way, if temperature you will increase or decrease, then again same thing will happen. It will readjust the equilibrium to avoid that change of temperature or that change of pressure. If gases, if one say pressure you are making change, then equilibrium will change. Then they will again readjust the equilibrium to avoid that change of pressure. Okay, this is actually LECT-104 principle. Now it's a statement I am telling you. That what is a statement? Then it states that a change in any of the factors that determine the equilibrium condition of a system will cause the system to change in such a manner so as to reduce or to counteract the effect of the change. Counteract the effect of the change. This is the statement of Le-Chatelier principle. Again I am telling you, Le-Chatelier principle, it states that a change in any of the factors that determine the equilibrium condition of a system will cause the system to change in such a manner so as to reduce or to counteract the effect of the change. Okay, this is applicable to all physical and chemical equilibria. Okay, this I have told you about the Le-Chatelier principles. Now little more I want to tell you. Okay, then listen carefully. One of the principal goals of chemical synthesis is to minimize the conversion of maximize. Okay, one of the principal goals means chief goals of chemical synthesis is to maximize the conversion of reactants to products while minimizing the expenditure. Means you want more product in less cost. More product, want more manufacturing in less cost. Means from the reactant you want more product. That is you can say maximization of products. Okay. Then in a less expenditure you want more product. Then there actually chemical equilibrium is used. That is the main, you can say, goal. Then here this implies means more product means this implies maximum yield of products. Okay, means economically you want production in less cost. Then here how will you get all the things? Then by the, you can say, chemical equilibrium, by the principle of chemical equilibrium you can get, and that is the main goals of the chemical, you can say, chemical synthesis, that in less cost you should get more by, you can say, application of chemical equilibria. Okay, that means a very simple way to maximize the conversion of reactant to product while minimizing the expenditure of energy. This implies maximum yield of products at mild temperature and pressure. At mild temperature and pressure, because to create more pressure, again special things you have require. Temperature also very high temperature, then again you have to do some things. Then these things we have to know, that how will you get the maximum production. For that, how much temperature is required, how much pressure is required, what are the conditions, we should know in advance. If it does not happen, if temperature and pressure you will not maintain, then you will not get the more product. Okay, if it does not happen, then the experimental conditions need to be adjusted. If it is not there, then only what you have to do, only in that whatever available temperature and pressure is there, in that you will make some change. Okay, then as for example in the Haber process for the synthesis of ammonia from nitrogen and hydrogen, this is very, very important from every point of view. In examination also question is asking what are the condition for temperature and pressure in the synthesis of ammonia from nitrogen and hydrogen. Then In that way it is also important. In the Haber process, for the synthesis of ammonia from nitrogen and hydrogen, the choice of experimental condition is of real economic importance, because all over the world production of ammonia is going on. And where this ammonia is used, why all over the world people are I can say producing ammonia in more quantity? Because this ammonia is used in making the fertilizer. Okay, ammonium phosphate. Okay, then it is used in the fertilizer, in making the fertilizer, production of fertilizer. That's why ammonia is utilized everywhere, all over the world, and it is manufactured in more quantity. Okay, and annual world production of ammonia is about 100 million tons. See, annual world production of ammonia is about 100 million tons, primarily for use as fertilizers. Okay, that's why it is important. And question is also asked. Equilibrium constant Kc is independent of initial concentration. Already I told you. Equilibrium constant Kc is independent of initial concentration. Whatever amount you are added, that is not no value. Okay, that equilibrium constant does not depend upon the, or you can tell independent of the initial concentration. But if a system at equilibrium is subjected to a change in the concentration of one or more of the reacting substances, as for example nitrogen and hydrogen, these are the reacting substances, then the system is no longer at equilibrium. Okay, here you have to understand. If a system at equilibrium is subjected to a change in the concentration of one or more of the reacting substances, as for example nitrogen and hydrogen, you are going to make change in the concentration, and it was already in the beginning it was in equilibrium. Now you are adding either nitrogen or hydrogen, then what will happen? Equilibrium will disturb. Okay, then the system is no longer at equilibrium, and a net reaction takes place in some direction until the system returns to the equilibrium once again. Okay, it will readjust, and again it will try to gain the equilibrium once again. Similarly, a change in temperature or pressure of the system may also alter the equilibrium. In order to decide what course the reaction adopts and make a qualitative prediction about the effect of a change in conditions on equilibrium, for that purpose LECT-104 principle is used. Okay, that after making any change, then what will happen, what course, in which course it will means you can say adjustment of equilibrium will happen, then which course it will follow. Okay, for that purpose LECT-104 principle is used. Okay, in order to decide what course the reaction adopts and make a qualitative prediction whether it will be less or more. To know all the things, LECT-104 principle is used, which already I have told you. Now I am focusing on the effect of concentration. Effect of concentration change. What will happen if you will change the concentration? Okay. In general, when equilibrium is disturbed by the addition or by removal of any reactant or products. Something you are going to make change means by addition or removal of any reactant, or you can say product you have removed, either reactant you have removed, or product you have removed, or reactant you have added, or product you have removed. Product only you have to remove. Okay. Then these things can be changed. Okay. In general, when equilibrium is disturbed by the addition or removal of any reactant or products, Le-Chatelier principles predicts that. What predicts Le-Chatelier principle? This you have to remember. First things you remember, if you are adding or removing any reactant or product, then what will happen? First things, the concentration stress of an added reactant or product is relieved by net reaction in the direction that consumes the added substances. Means, you suppose you have added reactant, then this effect, you have added reactant, then this effect of a reactant, what will happen? You have added a reactant, then how this effect will go? Then I already told you that they will get relieved. Stress means tension. That stress will be relieved. How? Then by making more product. Okay, by making more product, that's they will feel relieved. Okay, stress will go, because more product form, again they will come in equilibrium. This is according to the Le-Chatelier principle. Okay, the concentration stress of an added reactant or product is relieved by net reaction in the direction that consumes the added substance. Okay, means more production. Now second, the concentration stress of removed reactant. Suppose now you are removed the reactant. Okay, now you are removing the reactant. First case you have added, now you are removing reactant or product you are removing. Then what will happen? Again readjustment will take place. Then according to the Le-Chatelier principle, the concentration stress of removed reactant or product is relieved by net reaction in the direction that replenishes means substitute, because you have removed. It was in equilibrium, now reactant you have removed. Then what will happen? Then direction of the reaction will change. In that direction it will change, by which it will get, means it will get the reactant. Okay, in that direction it will change. Okay, replenish, that is called replenishes the removed substances. Okay, means it will readjust, equilibrium will be reset, will be readjustment, so that you have removed the this reactant, that effect will go, because it will readjust. Then this is also according to the Le-Chatelier principle. Then another words also you can understand, when the concentration of any of the reactant or products in a reaction at equilibrium is changed. When the concentration of any of the reactants or products in a reaction at equilibrium is changed, the composition of the equilibrium mixture change so as to minimize the effect of concentration change. to minimize the, equilibrium will change to minimize the effect of concentration change. Okay, this I have told about the effect of concentration. Now example you can see, by example also you can understand that suppose H2 and I2, hydrogen gas and iodine gas, both are reacting and it is forming HI, 2HI, H2 plus I2, that is equal to 2HI, all are in gaseous state. Now if H2 is added to the reaction mixture, in this suppose it is in equilibrium, H2 plus I2 is in equilibrium, it is forming 2HI. Now if H2 is added to the reaction mixture at equilibrium, then the equilibrium of the reaction is disturbed. In order to restore it, the reaction proceeds in a direction wherein H2 is consumed. That is, the more of H2 and I2 react to form HI, hydrogen iodide, and finally the equilibrium shifts in the right direction. Right direction means towards product. Okay, in the right direction means forward direction. This is in accordance with the LECT-104 principle, which implies that in case of addition of a reactant or product, a new equilibrium will be set up in which the concentration of the reactant product should be less than what it was after the addition, but more than what it was in the original mixture. Means that whatever either added or removed, anything, readjustment will, equilibrium will readjust to avoid that change, means addition and removal. Okay, and other things also you can understand it. This concept you can understand by Q. The same point can be explained in terms of the reaction quotient Q. Okay, reaction quotient Q. Then Q is equal to, know that Q is equal to, here in this case H2 plus I2, that is equal to 2HI. Then Q is equal to HI square divided by concentration of H2 into concentration of I2. Here why you are using the Q, why not Kc? Why Q? Then here, because now you are either removing some product or you are adding some reactant, some change you are making, then obviously it is not in the equilibrium. Then when it is not in the equilibrium, then Kc you can't use. Kc is used only when all will in equilibrium. But when you are adding or removing, then equilibrium is disturbed. Hence Kc you can't apply. You apply only Q. That is the, you can say, reaction quotient you can apply. Then Q is equal to here HI square divided by H2 into I2. Okay, means molar concentration of H2 into molar concentration of I2. Then now this expression, here Q is equal to HI square, HI is upside and down is H2 and I2. Then again you can understand, if H2 you are increasing, H2 value you are increasing, then obviously Q value will decrease, because HI is same, but down is H2, that value is increasing. Then obviously Q value will decrease, and when Q value will decrease, then what will happen? Q is now less than Kc. Q is less than Kc, means Kc is more. Then it will go to the forward direction, means more product will be formed, because Q is becoming less. Less means Kc is more. Always you have to compare both. QC and KC. Then QC is becoming less because H2 is in a denominator. Its value is more. Then obviously Q value will be less. Q will be less means KC will be more, and when KC will be more product will be formed. Okay. Then I have told you about these things. Addition of hydrogen at equilibrium. What will happen? I have told you. Now you can say these things I told you. Thus, in order to attain equilibrium after adding a hydrogen, I am talking about. Thus, in order to attain equilibrium, again reaction moves in forward direction. Similarly, we can say that removal of product. Now HI you are removing. HI you are removing. Then HI in Q expression, HI in the top, and HI you are removing. Then how it will affect to the Q? Q, now you are these things, you just understand. Suppose similarly we can say that removal of product also boosts the forward reaction. If HI suppose you are removing, and H2 you are adding, and product you are removing, then what will become? What will happen? Because you want to maintain reaction should be wants to maintain equilibrium. Then obviously product you are removing. Then H2 and I2 will react more and more, and it will give product because they want to make equilibrium, and product you are removing. Then it means H2 and I2 will react more, and again they will give H2 and I2 react more, and it will give product. Then on one side you add, you just continue adding reactant, another side you remove the product. Then it will be very, you can say, useful. One side H2 and I2 are adding, other side you can say remove the product, means HI. Then it is good. More and more product you will get. This is very, very important. Then either add H2 or add I2, same thing will happen. Or add both H2 and I2, same thing will happen. Because it is in denominator. Then Q will become less, then KC will be more. Hence more product it will give. And if product you will remove, then again to maintain the equilibrium, H2 and I2 will react fast, and it will react more, and it will give the product. This technique is actually used in the formation of ammonia from nitrogen and hydrogen. Okay. Then here I have told you this how product will be more and more, and this change is happening according to the LECT-104 principle. Now you can say in case of manufacture of ammonia, okay, ammonia is liquefied and removed from the reaction mixture, so that reaction keep moving in forward direction. Similarly, third example, in the large scale production of calcium oxide, CaO, calcium oxide, where it is used calcium oxide? Actually, it is used in it is very important building material. In building material, cement, main constituent is calcium oxide in cement. Okay, calcium oxide is the main, you can say, constituent. Other things are also mixed. Then in the manufacture of, in the large scale manufacture of calcium oxide, which is used as a important building material, then calcium oxide you will get from calcium carbonate, means decomposition of calcium carbonate will give the calcium oxide and carbon dioxide. Then in the large scale production of calcium oxide from calcium carbonate, constant removal of carbon dioxide from the kiln, K-I-L-N, kiln, drives the reaction to completion. Means product from the product side, you remove the CO2. Then as you will remove the CO2, more and more calcium carbonate will decompose. Okay, and you will get the calcium oxide. Calcium carbonate, after the decomposition, it is giving calcium oxide plus CO2. You remove the CO2, then what will happen? Calcium oxide will be only remaining in the product, and because carbon dioxide you are removing, then to maintain the equilibrium, more calcium carbonate will decompose. Okay, this I have told you. And this continuous removal of product maintains Q. Okay, continuous removal of product means carbon dioxide in this case maintain Q at a value less than Kc. Okay, because always you can say you have to, if you want more product, then Q should be less. Q should be less than Kc. Then in this way, if you remove the product, Q will be less. Okay, and when Q will be less, Kc will be more. Then more and more product you will get. Then this is the benefit of, you can say, this chemical equilibrium and this LECT-104 principle. All things are happening due to the LECT-104 principle. Okay. Now just these things, numericals is there. 2 numericals are there. I will discuss now, because that is based on the formula what I have discussed, relation what I discussed, that is based on that relation. Then here you can see question I am reading. The value of delta G star means standard. The value of a standard delta G for the phosphorylation of glucose in glucolysis is 13.8 kilojoule per mole. Standard delta G value is given 13.8 kilojoule per mole. Find the value of Kc. You have to find the value of Kc at 298 Kelvin. Then here in this question, the standard delta G value is given. Formula you remember, relation between 3 I told you na, Kc, Q and G. Then Q gone case you know. Okay, at equilibrium Q will go, but main relation is between the Kc and G, delta G. Okay, then that relation if you remember, then quickly you can solve the problem. Then here delta G, standard delta G value is given 13.8 kilojoule per mole, and you have to calculate, you have to find out the Kc. Temperature is 298 Kelvin. Okay, then this value is in the case of phosphorylation of glucose in glycolysis. In glycolysis, this reaction actually takes place during the you can say phosphorylation of glucose in glycolysis. Actually, this is the experimental. Okay, but that is not important. Important is there what you have to calculate, what they have given, what question in question it is given. That is important. Then here now very easily you can calculate that Kc value you can calculate very easily. How? Then here we can see delta G value is 13.8 kilojoule per mole. 13.8 kilojoule per mole. That is, you can calculate, kilo is there, na? Kilo you remove because you want only in joule. Then kilo means 1000. Then now you can write 13.8 into 10 to the power 3 joule per mole. Also, we know standard delta G is equal to minus RT ln K. That is the relation. Standard delta G is equal to minus RT ln K. That is the main relation. you are going to use this formula only. And ln k, here you want del k value, you have to put the all value in this relation only. R value are knowing, T value are knowing, K value want to calculate, delta G value are knowing. Means standard delta G is equal to minus RT ln K. Then delta G value is you are knowing, R value are knowing, T value knowing. Then ln K value first to calculate, and then after that from the ln K, K value you can calculate. Or direct K is equal to, already I told you, K is equal to exponential minus delta G standard divided by RT. Direct formula is there. Okay. Then now you can put the all value, and then you will get ln K value will get minus 5.569. Okay. Either directly K is equal to exponential minus you can say delta G standard divided by RT. That way also you can get direct value of K, or ln K value you get value of ln K, and from ln K, K value you can get by anti-log by seeing the chart. Then here ln K value you will get, that value will be minus 5.569 ln K. Then K value will be what? Exponential minus 5.569. Then from the chart you can see this, from the anti-log chart you can see, then K value will become 3.81 into 10 to the power minus 3. K value you will get 3.81 into 10 to the power minus 3. Okay, very easy numericals, but you should know to see the anti-log. Okay, anti-log, or you can say some, actually this is not mobile will be not allowed in examination. Then they will give a value, either they will give value or they will give in such type of this can say numericals that you can solve without the periodic this logarithm table. Without log table you can solve, or they will give the value in question only. Okay. Now second question I am telling you, second numericals that I am going to tell you. Hydrolysis of sucrose gives actually sucrose, ordinary sugar what you are eating daily, that is called sucrose, C12H22O11. Then sucrose plus H2O, it will give you glucose and fructose. Okay, equal amount, that it gives a glucose and fructose. So it is given the question, hydrolysis of sucrose gives a glucose and fructose. Equilibrium constant Kc for the reaction is 2 into 10 to the power minus 13 at 300 K. Value is given, Kc value is given 2 into 10 to the power 13 at temperature is 300 K. Okay. Calculate the delta G at 300 K. See, it is also very important. Delta G you have to calculate, and all values given. Okay. Means delta G, standard delta G is equal to minus RT ln K. Then here R value is given. You are knowing R value. Okay. R value is equal to 8.314 joule per Kelvin per mole. R value you are knowing. Always you remember. T value is given. T value is 300 Kelvin. And K value is also given. 2 into 10 to the power 13. Then easily you calculate the delta G. Direct formula is there. Then after putting all things value, you will get delta G standard value will come minus 7.64 into 10 to the power 4 joule per mole. Okay, this is the final result. Okay, very easy numericals. Delta G value you are getting, that is equal to minus 7.64 into 10 to the power 4 joule per mole. Today I am stopping only here. Again we will meet in the next class. Okay. Thank you.